Hello, everybody. We had a little malfunction at the Café Scientifique in early September, on the 12th of September, which meant that we accidentally didn't record the talk by the speaker, who I'm going to introduce in a moment. So what we're doing here is recording it a few days later, and I'm editing this together with the discussion which was recorded in the room on the night up in Pharmacology, and so that'll make one file for everybody to watch. So it's my great pleasure to welcome back Professor Klaus Ebmaier, and he did a fantastic talk, which you'll hear again now, and then the discussion on the night about his research and the things he's been discovering in the last few years. Professor Ebmaier, as he says on his first slide, is the Professor of Old Age Psychiatry in Oxford and a consultant psychiatrist, and very experienced and interested in this whole area. So over to you then, Klaus.
Okay, thanks very much, Rachel. I'll try to give the same talk as last week. And the way I started was by saying that I really see this as an extension of my clinic. Quite often what happens is that obviously, we exchange lots of information, and I try to come to a diagnosis and the treatment plan. And then quite often at the end, towards the end, I get the question, yes, but is there anything I can do? And that could actually come from the patient, or more often than not from the relatives. And they often don't just mean the patient, what I can do for the patient, but what can we do for ourselves? And I sort of expect that question, because if you read the papers these days, there's lots of good advice about what to do to prevent dementia, and quite often the time of the consultation isn't long enough really to give a differentiated answer. I tend to condense it into do what you think is healthy, and above all, do things that you enjoy, which is a little bit counterintuitive to most people. But let me try and justify this in a slightly longer version. If we can prevent dementia at all, the first question is, well, what's the good evidence that that is actually possible in principle? What makes us think dementia is just completely unavoidable? It happens to us as we grow older, and there's nothing you can do about it. In my mind, this best evidence that dementia can be prevented is indirect. It comes from looking at the frequency of dementia in population samples, which of course is done regularly, and it's done systematically using the same methods, so that you're looking at the same thing, in subsequent studies that often are 10, 20, 30 years apart. And the surprising finding is that if you look over the last few decades and you summarize all the results across studies combining tens, if not hundreds of thousands of participants, the bottom line is that the incidence rate of dementia has declined by about 13% per decade. Which means that assuming that the number of people at risk is the same, so the rate is given per 100,000, for example, or per 1,000, or whatever you like, but given the baseline population is the same, there's a 13% decrease in incidence. And this is certainly not something that is put across widely in the media. In fact, you usually get exactly the opposite message. And the message is that dementia is becoming more common. If it's formulated in the right way, you could say that the number of patients with dementia is increasing. Let's have a quick look at why that should be the case. You will probably be sort of familiar with population pyramids like that. As you go to the top, the pyramid has a top, and that's because people who are in the oldest age groups tend to die off. So the older your age group, the smaller the number of people in them. And then if you go down the ages, look at the ages in years in the middle column, and for comparison, you can see the date of birth, the corresponding date of birth at either age for both males and females. So if you look across the age groups, you can see that there's a bulge in the middle, and it pulls together again in the younger age groups, so people between 0 and 20 years are noticeably underrepresented. What's happening here is that you see this bulge, this increase in births after the Second World War. So after 45, 50, 60, maybe up to 70, the number of people born in each year was much higher than before and after. And what's happening is that these baby boomers are getting older and older, and they come into that age range where they're more likely to develop dementia. And that's where this notion comes from, that the dementia is becoming more frequent. So if you combine this information with the fact that actually the incidence of dementia is reduced, and just look at the global curve in red, you can see that without taking into account this actual continuous reduction in incidence, the frequency of people with dementia is just running away. It's getting larger and larger over the years. You can see this is projected up to 2040. If you take into account the 30% reduction per decade, you can see that it's maybe not quite as alarming, but certainly the absolute number of people with dementia still increases. If you only limit yourself to Europe and North America, it looks slightly less impressive, but still, even taking into account the reduction in incidence, the overall number of people with dementia tends to be on the increasing side. Okay, so far, so good. The fact that the frequency of dementia, the incidence of dementia is decreasing over the decades, of course, makes you think that there must be some environmental cause to that. The genetic makeup of the populations doesn't hugely change. So we're talking about environmental influences that reduce dementia. And if the environment is amenable to manipulation, to interference, by implication, you could say, well, this gives you some hope that if we only change the environment in the right direction, we can reduce the frequency of dementia. That information, of course, doesn't tell us at all what kind of factors are involved in making dementia more or less likely. But because it sums them all up, I think this is the most convincing evidence that dementia frequencies can be affected at all. Right, so let's think about how to figure out exactly which risk factors we should use to manipulate the frequency of dementia in the future. The most common use of risk factors is to predict dementia. So you examine a number of people, maybe a large cohort of people, and you follow them up, because unless you follow them up, you can't really say which feature or which risk factors in year one is going to predict dementia 10 years or 20 years later. So you need a longitudinal study. And then you also have to think about the kind of features that are likely to affect your risk of dementia. Unless you measure those features, you'll never know. So it's quite possible that these long-term studies haven't actually measured relevant factors, going back in time. So there's lots of things that potentially we don't know. For what it's worth, many of these longitudinal studies were set up when we were interested in heart attacks. And strangely enough, the risk factors that predict heart attacks and other cardiovascular disease also seem to predict dementia. That may be a lucky coincidence. It could also be that it's only those factors we've been measuring. But whatever that may be, I'll give you a list here of features that were available, and you can see that they're simple demographic features which are well, recorded. You imagine years of education, townsend deprivation, looks at the environment in which people live from their postcode, and you can tell how socially deprived that postcode was in terms of, you know, number of cars per household, number of people in a house, etc. You know, average income. Then many of these studies do hands-on measurements. They see how tall and how heavy people are. They take blood pressure measurements. They take blood possibly, and relevant measures, for example, here is blood lipids like cholesterol, and the fractions of high or low density lipoproteins, which are used to predict the risk of heart attacks. Then you have lifestyle measures, and you can see that that covers anything from things like sleep, physical activity, using alcohol, smoking, eating fish. Again, how many people live in a household, what weekly leisure activities do you engage in, and how many are these, and then do you suffer from sleeplessness. Then we know that the best predictor on a genetic level of dementia, which occurs later in life, is a gene called ApoE, and it's this ApoE4 allele. This is one particular version of the ApoE gene, which is associated with a higher risk of dementia. And then in those studies, we tend to be very good at recording medical history. You know, that's what we're accustomed to. And most of these studies have measures whether somebody has a history of depression, diabetes, stroke, and you can see they go through a whole gamut of conditions that are vaguely associated to a cardiovascular disease. Aspirin, which is a common treatment, HRT, which is sort of topical and interesting, and then the history of dementia in parents. So these are the kind of features that are available, for example, in very large studies like the UK Biobank study. And the first thing, if you look at such a list, is that there's actually some overlap. There must be some redundancies. So, for example, insomnia, sleeplessness must be related to the number of hours somebody sleeps per night, or numbers living in a household must be related to the Townsend deprivation index, and so on and so forth. So there's going to be overlap between many of these factors. And in order to get the most efficient prediction of dementia, you have to extract a limited number of these features which express the largest variability, say, in risk of developing dementia later on. And we've done this recently. This has been published just the other month in B&J Mental Health. And these are the factors that have made it into the final selection. You can see that there are some previous illnesses like stroke, diabetes, being hypertensive, having high cholesterol, you know, all these high vascular risk factors predict dementia later on. Depression does, that's been reported and commented on several times. Parental history presumably does, because there must be a genetic element to this. Age does, and this is an interesting feature. Normally, age is the single most important predictor of dementia. You know, the older you are, in fact, if you develop any kind of scale that pulls together risk factors, it tends to be marginally better than just going by age, right? But you can see here, age is well in the middle field, so it's about 20%. If you have a higher age, obviously these would be divided into halves, and so if you have a higher age, you have about 20% higher risk of developing dementia. And that really explains how these risks are combined. You're actually looking at the unique contribution of any of these factors. So this is age after you've already taken account of other things like stroke, depression, diabetes, cholesterol, hypertensive. You know, after these other factors have been taken into account, these other factors which are also associated with age. Okay, so if that makes any sense, these are the unique contributions of any of those factors. And if you combine them, you get the best possible prediction of risk of dementia over the next 14 years. You can see on the furthest right, education is actually significantly below the line of equality. So if you have a higher level of education calculated in years, the risk of dementia is lower than on average. Everything else adds to the risk. And I did have in the previous slide, I did have ApoE, which is the single most important gene for late onset dementia. And if you stick that in as well, we did this analysis separately because genetic data are not available for everybody. And if you want to have a useful index or calculator for risk, you have to have a version with and without the genetic information. So in this case, we added it in, and you can see that it's the single best predictor. So it's if you have the wrong allele, the wrong version of the gene, your risk of dementia triples over the next 14 years. And certain other risks, if you go to the furthest right, high cholesterol becomes not significant, which is good because we know that ApoE has something to do in the transport of lipids in the blood. So it's involved in the transport of cholesterol. And once you've taken account of the genetics, the actual cholesterol measures are not so important any longer. So you can see there the overlap between those factors, even if you concentrate on the most important ones. Okay, so this is if you try to get the best possible prediction of the risk, and talking about the environment and doing something about it. Of course, there are quite a few things that can be changed, maybe over decades or centuries, but actually for the single person, they're not changeable. You know, once you've got a stroke, you've got a stroke. There's nothing you can do about it. Similar with depression, diabetes, and so on. Parental history, you can't do anything about. Townsend deprivation, well, you know, our ideology suggests that you can lift yourself out of your environment, but actually it's not as modifiable for the single person as you would wish. And there are other things like education, which you can't change in retrospect, or whether you live alone at the time, that may be partially due to you, but it also is determined by other factors, like whether your partner has died. So there are lots of these risk factors that are environmental, but they're not really amenable to manipulation. You can't sort of take them and say, okay, I'm going to change this and this and this and this, and then we reduce the risk of dementia for the next 14 years by so many %. So it's not very useful. It may be efficient in prediction, but it doesn't allow you to find strategies to prevent dementia, which is an important point to make, because if you publish a paper like we did on risk factors, and you see how it's reflected in the media, you can see the sort of typical mistakes that are being made and are being passed on to the readers. So the first sentence of this particular article was, the new dementia risk code identifies people at risk from midlife onwards of developing the disease within the next 14 years. That's completely correct. That's grasps the essence of the paper. And then the second sentence says, but targeting key risk factors, several of which involve lifestyle, could potentially avert around 40% of cases. And this is the other number that's been widely, doesn't come from our study. It's something that we cite in the paper. But it's certainly become common knowledge that you could prevent 40% of dementia. And of course, that is not implied at all by our results. And although it's understood, if whenever you see something about risk of dementia, immediately get this notion, oh, you can actually prevent almost half of the cases. So let's look at that in more detail. And there you have to essentially say you're looking at risk factors to prevent dementia. So that's different from predicting it. And the paper I'm mainly referring to, it's a series of papers published by the so-called Lancet Commission, last one in 2020, Dementia Prevention, Intervention and Care. And in that paper, they identified 12 risk factors, and they selected them not in terms of the efficiency of predicting dementia, but in terms of that they are potentially reversible, although clearly, to a different degree. And secondly, that they affected large number of people in the population. So in our study, for example, hearing loss didn't figure at all. In this, hearing loss is fairly high up, and that is partially because there is a correlation between hearing loss and later dementia, but hearing loss is really, really important because it's very common in the population. So if you have a loose association with dementia, but there are lots and lots of cases, of course, the general importance of hearing loss must become more relevant. And essentially, they took those two aspects, the degree of the correlation of the risk factors with dementia and how common this risk factor is in the population, to identify the 12 modifiable risk factors of dementia that are most important and most useful to look at. You can see that many of them overlap with the previous one, like hypertension. And in fact, in that paper, they acknowledge that treating hypertension is the only known effective preventative medication for dementia, which makes sense if you look at the statistics, and also to some extent it may explain the fact that the frequency of dementia the incidence of dementia has gone down over the last decades. High blood pressure being treated has been one of the targets of general public health, and the GP's daily bread. They identify people with high blood pressure and they treat them for it, and it may have led to some fruition as a result of it, not only in terms of heart attacks, but also in terms of dementia. Okay, so you can see there are lots of factors there, some of them the same, but some of them completely different. And in order to figure out exactly how to interpret these risk factors, I think we need to look in slightly more detail what a risk factor is. So there's the 40%, just in case you'd forgotten. So let's identify or define what is a risk factor. It's just essentially, it's a mathematical term. It means that if you have a feature, that means your chance of developing dementia is greater than if you don't have that feature, then this feature is called the risk factor. Okay, so it's essentially just derived from the fact that if you compare the people with and without this risk factor, the ones with have a higher risk of dementia down the line. That doesn't tell you anything at all about why there's this association. So let's go a step further. The first assumption is always, well, if you have a risk factor, of course, that is important because it's on the causal chain. If you have that risk, for some reason, in the end, you end up with dementia because, let's say, high blood pressure affects the quality of your blood vessels, and if your blood vessels are disturbed and damaged in the brain, in the end you end up with dementia. So there's a kind of causal chain that you can understand. And if you mention risk factor, that's usually what people have in mind, and that would explain this confusion about predicting dementia and actually being able to do something about it. So that's not really, that is straightforward and easy to understand. But risk factors can also be early symptoms which occur before the diagnosis. And in fact, they're more like early markers. So if you think about time going from left to right, people are healthy, then they have some mild cognitive impairment, and then they develop dementia. Actually, while all this happens, this underlying dementia process already was going on. And even at the time when people would qualify to be healthy or just mildly cognitively impaired, there was this process going on that already could be measured in some way. This is often described as reverse cause, as if time goes backwards, and cause things in the future can cause things in the past. Which of course isn't the case, but it only means that if you're diagnosed with dementia, it may mean that there have been some changes in your body, particularly in your brain, and that have been going on. And we know about changes that go on for decades, even up to 20 years before you have a diagnosis, that may already be noticeable by certain measures and by certain observations or symptoms. And of course, if you change those very early symptoms, you're not going to make any difference to the likelihood of people develop dementia at the end. You basically just just deal with symptoms that may or may not be important for the further development. And then the third common situation is that you have risk factors that are due to a common original cause. And so some of those risk factors may actually causal. So if you follow their causal action, you end up with dementia. But others just end up with, others are markers, but they're not on the direct causal pathway. Let me give you an example. You may just remember from this slide before that being male increases your risk of dementia. Everything else being equal, being male increases your risk of becoming demented over the next 14 years. And, you know, we don't know for sure how that happens. Some people have argued that women benefit from having high levels of estrogen, particularly pre-menopause, and that has a beneficial effect on cardiovascular function, including then dementia. But the exact causal pathway isn't known. So if you think of dividing people in men and women, that's a trivial thing to do. You could do it if you have genetics, or even have a look at a cell. You can tell who's got X and Y chromosomes. Usually you have to measure these original common causes indirectly. One way would, for instance, in terms of men and women, you could look at levels of estrogen, and you probably find that levels of estrogen are likely to be predictive of dementia, and that higher levels produce a lower risk. The other thing that are different between men and women is shoe size. Men tend on average to be a little bit taller and bigger than women, and that extends to the feet. And if you just measure shoe size and use shoe size as predictor of dementia, you probably find that the bigger your feet, the greater the risk of dementia. And that is probably not on a direct causal chain to dementia. And you can think how bizarre it would be if somebody suggested, oh, let's all reduce people's shoe size, give a boom to plastic surgery, and then we reduce dementia. You can see how absurd that is. But that's because shoe size is a marker of being male and female. It isn't actually on the causal pathway to dementia. And so in summary, in both cases, both in the reverse causality and in common underlying cause, you may not be able to reduce the probability of dementia if you change the risk factor. And then just a final comment that some risk factors may actually be related to true causes of dementia. For example, if you look at the deposition of amyloid in people's brains, that's how the diagnosis under the microscope of Alzheimer's is made. And that's how we think dementia comes about. We don't know exactly how, but there's probably a relationship between amyloid deposition, although that happens very early in life. And then, of course, the immediate therapeutic reflex is, oh, what we do is we just remove amyloid from the brain. And this is what all these new drugs are about. They basically capture amyloid by monoclonal antibodies and hopefully remove it from the brain. But unfortunately, even if you do that, you end up with people who are not very much less demented than they would otherwise be. So the benefit of these drugs is very limited. And that could be because, you know, it's all bang on. There are risk factors, they're on the causal chain, but by the time you've actually done something about it, it's too late, because it's not actually the amyloid itself that is dementia. It is the damage that the amyloid has caused already. Okay, so this is really just to show you the difficulties to make the jump from risk factors to prevention. And what I want to do in the last few minutes is just go through a few examples of this list of 12 risk factors, just to make this conclusion, put it into context and make it a bit more plausible, that you have to be very cautious with drawing conclusions like this. Let's start with hearing, because that's very common. And going back to this particular paper, and this is lifted from the paper, the thing they recommend is to encourage the use of hearing aids for hearing loss and reduce hearing loss by protecting ears from excessive noise exposure. Okay, So unfortunately, it's so late for me. I've listened to very loud music and I played electric guitar. So it's not a modifiable risk factor for me. And in fact, I have some hearing loss. I do use hearing aids, but I'm subjectively very aware that they can only help so far, particularly if you have a noisy environment with lots of clutter and high frequency noise. The hearing aids actually make it worse. And that made me think, actually, hearing loss is not primarily damage to the inner ear. There may be lots of other factors that are involved. Everybody listening to this will be aware of the situation that somebody's been talking to them, but they've been engaged with something more interesting or more important, and then suddenly they're being shaken and said, "Oh, you're not listening to me. I can tell you're hearing, but you're not listening." And that really proves that the process of hearing is more complex. It's a combination of the cortical parts of the brain, the central bits for information processing of the brain, actually controlling the input in some way. And if you have a problem with hearing, it may be a mixture of those two processes. So it's not sufficient just to turn up the volume, but you also have to be able to process it properly. And nevertheless, you can actually look at it empirically. So one of my colleagues here in Oxford, Sarah Baumeister, looked at large data sets of people who had hearing impairment, and where it was also recorded whether they used hearing aids. And what she found is that if you had hearing impairment, that predicted dementia. If you had hearing impairment and you used the hearing aid, that didn't predict dementia. And if you have hearing impairment and didn't use the hearing aid, that really explains why hearing loss causes or is associated as a risk factor for dementia. And of course, that would, at first sight, would sort of underline this notion, if you keep the input going, the hearing aid, keeps generating the noise, which then, the significant noise rather that arrives at the brain. The damage to the brain can be prevented. This is really on the basis of, use it or lose it. So if you don't get the input to the brain connections that are established as a result of listening to language or anything else meaningful, break down, and that leads to dementia, or at least increases the risk. But there's a different interpretation to that, because we know that people with dementia have greater trouble picking out language from noise, so their ability to identify significant signals from amongst noise is impaired, probably because the cortical areas, the information processing areas of the brain are already affected in them. And in my mind, it's quite possible that people with who then go to develop dementia are not using the hearing aids or don't benefit from them because they just don't manage to extract the signal from all the noise. So the fact that they don't use the hearing aids, it could be because they're just forgotten, which is an early sign of dementia, or it could be because they cannot interpret the louder sound, which includes noise and significant language, for example, as people without pre-dementia can. So there are different interpretations of this, and I have to be very careful to draw the conclusion that by just reducing noise exposure early in life or giving people hearing aids, we can prevent dementia from happening. I should say, for all these factors, of course, there's no direct evidence. If you wanted direct evidence, you would have to basically offer some people hearing aids, and at random, you prevent them from using hearing aids, and then you look at them 20 years later and see who's demented. That's both, it's both expensive, it's impractical, and you could argue it's unethical. So you can't randomize people to lifestyles if you think that one or the other is problematic. I was going to talk about obesity, and close to obesity is also physical activity. And they're already a little bit cautious here, sustained midlife and possibly later life physical activity. I think they're picking up on the observation that even before you develop dementia, you sometimes develop something called apathy, So people who later develop clear-cut memory problems tend to show less initiative, narrow down their circle of activities, narrow down their social activities. So everything that is connected typically with risk of dementia may actually, in this case, be an early sign of a pre-dementia process that's already going on. And that's particularly striking if you look at obesity. The traditional theory has it if you're overweight, if you have a high BMI, if you're obese, you increase the risk of vascular changes, heart attacks, strokes, and by implication, dementia. But if you want to prove that link, you actually have to follow people up, or you have to go back from the diagnosis of dementia for about 20 years. Because only if you go back far enough, you get this unambiguous association of being overweight with increased risk of dementia. And that is because as the people get older and they come towards being diagnosed with dementia, for about 10 years before the diagnosis, they already are eating less, they typically lose weight, their BMI goes down. And if you then, at that stage, measure their BMI, you actually find that it's the thin ones who are more likely to develop dementia. And that's not because being thin is a risk factor or is a causal risk factor for dementia. It's an early sign of you going to develop dementia. So these are a couple of examples of how this reverse causality and multiple causation can mess up your results and make it the wrong conclusion to say, well, if you do something about it, you can prevent this from happening. And the last example I want to talk about quickly, because that's my actual area of interest, is depression. We try to answer that question by looking at one of the longest cohorts in this country, the so-called Whitehall cohort, who've been followed up for more than 30 years now. And they were one part of this crop of cohorts trying to go to the bottom of why people develop heart attacks, and they looked at other things like stress and so on and so forth. And they also measured depressive symptoms every couple of years. So we have measures of depressive symptoms every 2 years over the last 30 years, and we know who in the end develops dementia or not. So these are the orange ones are the ones who finally diagnosed with dementia. The greeny blue ones, the ones who don't develop dementia, and 0.0 at the right end of the x-axis is when they have the diagnosis. So all the minus numbers are years before the diagnosis. So if you compare those two groups in terms of depressive symptoms, the most striking is that they don't hugely differ until about 10 years before the diagnosis is made. And then from year to year, more and more people present with more and more symptoms of depression. So it's almost as if an underlying process that leads to dementia makes it more and more likely that people also have depressive symptoms. And if you look at this graph, you would think, well, depression clearly is an early symptom of dementia. It's a kind of, it's a marker that indicates there are already things happening with your brain. I could talk for another hour about why that should be the case, but the striking thing is that, this is most likely to be a reverse causation effect than a causal risk factor. And that's certainly true for depression in the 10 years or so before the diagnosis. There's a case to be made for depression earlier in life. You can see that the two graphs show slight differences, although they're not quite significant here, 20, 30 years before the diagnosis. But that relative increase in risk is quite small compared to the one you get closer, if you're depressed, closer to the dementia diagnosis. So that all sounds pretty typically scientific. We thought we knew something, and now we know that we actually don't know it at all, and possibly we've got it all wrong. How can we get around this? I've mentioned randomized controlled trials, and because these are risks that occur over years, even decades, it's actually very hard to have a controlled study of that. And you cannot really practically randomize people into lifestyles in this way. So what else can you do? In order to try to figure out whether reverse causation plays a role, you need to follow up people for a long period of time. And as you can see, if you look at BMI, you have to follow up for about 20 years because you figure out exactly what role is being played there. So that's an important component. Short-term studies, therefore, are not particularly helpful. Then I mentioned about us actually only measuring cardiovascular-related features because that's all we could think of at the time. The trend now is to measure everything you could even think, everything you can measure, and then hope in the end it's going to shake out as some significant association between one of these features. That is it's a bit expensive, of course. It's also deceptively simple because for statistical reasons, the more things you measure, the more people you have to measure it in order to have some reliable, in order to be able to draw some reliable conclusion. Okay, so that's another approach, deep and frequent phenotyping. And the last approach I just wanted to mention is has really developed over the last 10 years or so, and it essentially it relies on the fact that most of the features of the risk factors, as it were, but also most of the outcomes, like for instance dementia, can be characterized by or can be associated with genetic information, with genes, or more typically something called single nucleotide polymorphism, so-called SNPs. So there's a connection, there's a combination of SNPs for virtually anything you can think of, from shoe size to intelligence, to any particular biochemical measure in the body. And if you can concentrate on the bits that are associated with this genetic information, you can circumvent the argument that somehow there's reverse causality involved, because the SNPs are determined right at the beginning of your existence. So, you know, that reverse causality doesn't come in it. And also the SNPs are really thoroughly mixed up in every single subject. So occasionally it happens that they are correlated with each other, but by and large, they're not. Which is called linkage equilibrium, and that's partially due to the fact as we are being formed from single or rather two cells, the genetic material is thoroughly mixed before the individuum, the zygote, is formed, so that all those genetic features are more or less randomly associated. So you can use this information almost like in a randomized trial to see whether a particular risk factor, or as expressed through its SNPs, is causal to a particular outcome, again, represented by the SNPs. So this thing called Mendelian randomization, if it works, obviously there are lots of methodological issues around it, but if it works, it can help you throw out quite a few of these risk factors that can be shown not to be causal. And just as a footnote, if you look at those 12 risk factors I mentioned, the ones who can remove 40% of your risk, there are only 1 or 2 or 3 of them who actually who can be shown to be causally responsible for dementia. So in a way, it's the 40% is an absolute maximum estimate of what can be achieved. I think it's extremely unlikely that it ever can. It'll be much, much less than that. And that's the reason I would tell people, well, you know, there are lots of things that are healthy, and everybody agrees that they're healthy, anything from movements to, you know, not living on burgers. But most important of all, you know, do the things that you enjoy doing, and you've got a limited time and to worry about the evidence, the statistical evidence, or even to follow the papers and the recommendation, I think would just be misguided. Yeah, thanks very much.
Thank you. Thank you very much. I'm going to stop recording this and edit it into the discussion, and on which there is a proper thanks to Klaus at the end. But thank you particularly for coming back to re-record. Lovely.
You're welcome.
Obviously, we've got a speaker down here because not everybody has the same hearing capability as everybody else. So we always have one in the room so people can hear. For that reason, we would like you to speak into the microphone. We'll pass it around. We have another one which doesn't work quite as well. If we get an argument going on, we'll bring it out. But generally, myself and Neil will make sure it gets to you. Please, when you have it and you're saying something, please can you hold it the way I am, with the handle, and pointing at your mouth. It doesn't work if you do this. It doesn't have any effect at all. I promise you, we'll be over and we'll shove it up near your mouth. It's got to point at your mouth. That's the point of the handle. For the people online, we're going to start with people in the room and then we'll come to some of the comments and questions online, which there are. And it should now be saying that it's recording. So hopefully everyone will see that.
No, I just switched it off. It did show.
Perfect. Excellent. And in which case, who would like to start? I sprang that on you a bit quickly, didn't I? Yes.
Have you ruled out the possibility, bearing in mind, as you say, men get dementia more than women, have you ruled out the possibility that men have more brain injuries, more cases of concussion?
This list of factors you saw is the result of taking into account all those risk factors at the same time. I skipped that bit because I knew it was running late anyway. But what happens in a statistical model like that is that if two overlap, you basically just focus on the bits that are unique to one or the other. You may have noticed, in fact, I can take you back to this list. I can see it moving, but what I'll do is I'll just... No, it doesn't. Oh, it actually, the problem is that it was the end of the slideshow. Can you just start it again? For some reason, it got stuck on the last slide rather than conking out. Yeah, that's fine. Let me just go back. Yes. So this was the first model, which essentially uses all the measurements and behavioral measures apart from the one genetic one. Okay, and age is here, right? Usually, if you try to predict whether somebody develops dementia or not, the really most important factor is age. Okay, if you had to pick one, you would pick age, because the older you are, the greater the risk of developing dementia. What this does, it actually takes all the other factors into account. And this is what's left of age, for example, once a history of stroke has been taken out, because that's age-related as well, or hypertension is to some extent. We did sex is in here, of course, but in the original list, you probably remember there was, or was there head injury as well? There wasn't, and that is partially because, it's a technology foresight that's lost us there, because 20 years ago, we didn't really know about rugby players and football players who were heading. And, we could have said, men are more likely to fall off a motorbike and have a head injury, but it wasn't systematically examined. So we actually don't have that in there. So the answer to your question is yes, it could have been, that could be one of the reasons why men still have an excess, because head injury wasn't included. If you really, to control for that properly, you would have to take a life history of, have you played football? Have you headed? Have you played rugby? Have you been boxed? How many times have you been knocked out? These things have to be acquired to be able to control for it properly. So quite right.
I guess as well, that's one thing you can retrospectively add in, because you can say how many times this has happened and when, if you're playing football, what age were you? Whereas there are other things where you can't find that out afterwards or control for it in the same way.
And of course, the longer you wait, the poorer the memory to actually recall it. And you may find that the guys who start developing memory problems actually have less of these risk factors because they can't remember. So you have to keep that in mind.
So we've got somebody asking just a general question about risk factors. So how tightly are they defined? For instance, they say depression, do you divide it into maybe continuous, regular, occasional, just seasonal affective disorder? And says also, in my younger days, the history of being more depressed than my doctor was a good boundary condition. Just saying, how tight are these categories?
Yeah. Good question. I think the definition depends on the study, and that's why, if you read a study, you have to go into the method section to figure out exactly how did they measure this. And unfortunately, it varies because there's no obvious right way or wrong way to measure things. Depression is a particularly bad one because we use it just to describe depressive mood or depressive symptoms, but then it also used to describe a whole combination of symptoms, which we call major depressive disorder, and you have to basically fulfill certain thresholds for all sort of symptoms to follow that. So depression is not depression, and in any of those comparisons, obviously, we've been trying to harmonize these and try to get the closest possible definitions of these factors. I mean, some features are relatively straightforward, but even if you have male and female, these days you have male and female, and then you have gender, which can have all sorts of other expressions, and some studies may have that and some may not. So you can see that it's actually quite difficult to make studies comparable in this way.
Thank you. Staying on that for the moment, somebody was asking, just to clarify, they weren't sure if they'd missed it. Does treatment for depression, whether psychological or pharmaceutical, help mitigate dementia risk?
We know that if somebody has depressive symptoms, or if they have to a slightly greater extent, if they have a full-blown diagnosis of depression, are more likely to end up with dementia than people who are not. As I showed, it may actually be that the people who have the depression developing in later life, after 60 or so, may actually already show the early signs of dementia. In that case, my guess would be, but the short answer is we don't know, because nobody's done these studies. Nobody's that, for instance, taken people and treated them with drugs, or treated them with psychotherapy alternatively, and then see which of them end up with a dementia at the end of the day, because you can imagine that takes lots of money. You have to randomize people into those treatments. You may actually be able to use old studies where that has been done for completely other reasons, and then you have to follow people up and see what becomes of them. But it's, there's not enough time lapsed for that to happen. These are certainly projects that are being thought about and are being done. But I think the short answer is we don't know. We know that people, if you just look at the genetic element of depression and look at the genetic element of dementia, there's no evidence that the two of them are causally linked, in the sense that depression causes dementia. So I would be skeptical whether treating depression is actually going to reduce the risk of dementia later on, unless it involves anything that actually is on the causal pathway to dementia, which these treatments usually are not.
I was just wondering, on the looking where somebody comes up with a new factor, is the biobank data in time as you get, I think it's been going, 23 years, something of that order?
Yes.
As that, the information, when you get much younger people going on and coming through, is that going to help with, if you come up with a new factor, you search through backwards to get to it?
Yes, that's certainly been done, and one of the idea behind biobank is, we just measure everything, everything that can be measured. Who knows what it's going to be good for at the end of the day? And I think that's a sensible thing to do, particularly if you have huge numbers of people as in biobank. But you have to be lucky. Sometimes you find those and sometimes you don't. And sometimes you can only measure, you learn to measure things, and you couldn't measure them before. So, you have to acquire new data for that. That's where this sort of deep and frequent phenotyping idea comes from. Let's just acquire all the data we can. And it's a great idea scientifically. It's sort of, I would imagine it gets onto the participants' nerves a little bit, what do you need to know that for? There's a kind of, well, I know, but I think that there's that as well to consider, what information you're going to collect, because we have data protection laws that allow us only to collect the data that are actually needed for something. So this, you can see that already in this case, that's slightly stretched. But that's one of the paradoxes. In a way, it's interesting that all the convincing risk factors for dementia are the convincing risk factors for heart disease and stroke. Because those are the ones that we knew about 20, 30 years ago, and those are the ones that were acquired. And many of the cohorts that have been around now for 20, 30 years were based on, let's examine the causes of heart attacks.
Just going to see if this one works. Is that a bit fuzzy? It's all right. Yeah. Behind to Gestalt Leo. Question for me. We now have large groups of the population on medications for many years. So you have, heart benefiting drugs, you have reducing cholesterol, you have women on hormones for years. Lots of these. Have any of these studies gone back to try and connect up that information or not?
So I was trying to go back. To this slide. And it's a very obvious question, because what has happened what happens over the decades, people's lifestyle changes. One of it is that they take sort of all sorts of pills, of course. Others are that they become more aware of their health. And others may be completely banal. They're richer, their diet is better. They're not exposed to as many noxious substances. And I guess one example is exposure to air pollution. Of course, you don't have data for every single person. You have to have sort of a detector next to everybody. But what you can do is you can look at historical data of pollution in particular districts and see where people live, and then see whether you can find any connection there. And people are starting to do that. But you can see there are lots of different factors to keep in mind. And if you have in one group, you have information about one, you may not have information about another. To actually trade them up against each other is going to be a bit difficult. But it's, as an idea, I think it's certainly there.
Yeah. I'm not going to carry on with that one. It's too loud or not.
The one thing I would say about that is the measure of pollution is quite a simplistic one historically. Even in the last few years, and we had somebody come and talk to the cafe about this during the pandemic, we're starting to be more alert now to the very, very small PMI particles given off by tyres of cars and thrown up from the road. And more of us now in Oxford are cycling, to look after our health in that respect and to reduce pollution of other kinds. So it isn't just nitrous oxide.
That's what I meant. Clearly, it's much more differentiated. Pollution isn't, then isn't pollution. What you consider pollution now, because we're much more differentiated. Idea of it, don't we?
Yes, it's interesting that you've lumped dementia all together. Is there any differences between the different types of dementia and the risk factors?
Yes. This is a really interesting question because, if you've gone through medical school, you're quite categorical. There's Alzheimer's disease, and you have plaques and tangles, and there's vascular dementia, and you have little strokes, and then there's Lewy body dementia, and you have Parkinson's disease. But actually, many of these studies are just based on dementia or whatever, right? So there's actually, and that's a practical thing to do. It's not a strange thing to do because the risk factors overlap to a large extent. And it's partially because, if you have Alzheimer's disease, part of your problem is not just the plaques and tangles. You also have an involvement of your blood vessels and the consequences of that. So, what actually is diagnosed as Alzheimer's disease, as a sort of rule of thumb, because nobody actually looks at the brain under a microscope, includes people who already have some blood vessel changes. And it's quite common to have visible blood vessel changes on scans in Alzheimer's. So I think it's a very apt question in the sense that what we thought were distinct categories actually show quite a bit of an overlap. Even if you ask a pathologist, who just looks at the appearance of the brain and who measures or does the chemical analysis of, for instance, Lewy bodies or Alzheimer's plaques and tangles, they will admit that most brains actually have a mixture of all of that. And for instance, people with Lewy body disease have Alzheimer's plaques as well, and which contribute substantially to the kind of memory problems they have. So it's really not quite as simple as that, and unfortunately, there's no simple test. Well, and I should go one step further. For instance, in Alzheimer's plaques is the sort of, they're named after Alzheimer. They were discovered and described initially, but they actually occur in lots of people well before they develop Alzheimer's disease. So if you can show plaques in somebody's brain, for instance, you can image that. Now, it doesn't mean they have Alzheimer's. It's more the other way around. If they have dementia and they don't have plaques, and say, well, they probably don't have Alzheimer's. Right? So it's that degree of certainty.
Thank you. I'm going to do two from online. One is a comment first, which I quite like. Lisa pointing out, if you feel depressed about the fact that your mother has dementia, then you're simply doomed. In other words, genes combined with depression. But more seriously, somebody else asking, should the population be screened for the APOE4 genotype?
Okay. Well, if you're depressed, and not just sad, which I think is a completely normal reaction, but you can't sleep, your appetite is poor, you can't concentrate, you feel worse in the morning than in the evening, and you have all these other symptoms that build up to a depressive disorder or illness, build it up to there may be something actually done about it. I don't care whether it's psychotherapy or medication, but it's certainly something that can be done. And people usually say, I'm depressed because of, but quite often, that because of is quite irrelevant. You have to attach some meaning to why you feel depressed. Actually, you could also be not depressed while your mother is developing dementia. So there's no direct connection there necessarily. And I don't think she's doomed. I actually think, I see lots of people with dementia. I enjoy meeting them. I enjoy seeing them enjoying life. And I don't care if it's sitting in front of a big piece of cake, and it's so enjoyable to eat, but they can't remember, who the visitor is. Well, who cares? It's, you should enjoy life as it is and when it happens. And I don't think there's any point in sitting there and grieving about that particular bit. You can grieve about the parent who's no longer there in the same form as before, but that's your own private problem. Your mother or your father may actually not be aware of that at all. They're quite happily, living as they do. I speak from experience in the sense that my father developed frontotemporal dementia, and he was a much nicer man afterwards. He actually was much more relaxed, much less stiff, and he could enjoy things much more than he could before he developed dementia. So it's not all negative. I think it's important to focus on the bits that that different, but that are not necessarily worse than they were before developed illness. And I find that in most couples, or even children and parents, you can develop a way of living that's different from how it was before, but that's quite enjoyable, with lots of laughter and doing things together that both enjoy. And so I don't believe this doom story. I mean, there may be all sorts of reasons why you bring this up, but I don't think they're necessary consequence. I think the second half of the question was.
Yeah, I think, by the way, I think that may have been a joke, but anyway. The second part was somebody else saying, should everybody be screened for the gene you referred to? Yes,
that's an interesting question. And I think the answer is, how much money have we got? And would people be happy to be screened? We did this European study when that was still possible. I think in the end we had 27,000 people who across Europe answered that question, and the answer was yes. We want to have tests, we want to be screened, we want to take part in this in an active way. This was, of course, relatively an abstract question. We didn't offer them a particular test, but people seem to be quite ready to get involved and to do it. If they're prepared to pay for it, we're going to do it.
Got a question over here.
Following on for your comment about sort of enjoying it as it is, I agree with that up to a point, but then the latter stages are really awful, and they're really sad when the person can do almost nothing, and I think then that's when it really hits. I've got another comment to make. It's going to be a bit flippant in a minute, but I'll leave it there for the moment.
No, I mean, I agree with that. And for every carer, if that's a word at all, I think there's a point when they have to think, can I carry on like this? And that may be a completely subjective thing, that they feel they can't. Or is it in everybody's interest to carry on? Because there's a certain level of dependency that can really only be managed if there are two people involved. Otherwise, the single person is going to put their back out, and they're going to be sick for the next few months. So I think it's quite important to start sharing responsibility, and if that's at all possible, try to focus on the quality time that you can have. Things that are still enjoyable, and leave the heavy lifting, as it were, to others. And that's a very difficult decision. I know that if you are with somebody, who you have cared for up to that point, you really don't want to hand over. But it's, I find it's not that relatives want to get rid of their patient relatives, that carers want to get rid of them. It's the other way around. I have to persuade them that, look, it's quite important for you to share some, because you're the most important person in their lives, and it's important that they have the time. They have good times with you, rather than having to fight with you all the time. Probably inadvertently, because they, whatever their resistance is, not against you, but it's doing something different from what they expect. So that's certainly. I mean, there are two transitions. There's that transition, and then there's the first one where you have a patient who before then was in charge, and who you relied on in lots of ways, and you have to do this 180-degree tilt and say, actually, now I am going to determine what's good for you. Seems wrong, seems completely wrong, but everybody has to go through that stage, and for children it's particularly difficult, as one would imagine. But so it takes a bit of persuading, but I think it's the only way to go.
Can I make one? Rather, you may think it's rather flippant, but for somebody who spends a lot of time at the moment in a very good care home, I'm saying to all my friends, and particularly younger people, for God's sake, look after your teeth, because one of the biggest problems in care homes is people who have false teeth and plates, because they all disappear, and it looks terrible, and it's a big problem for you. So look after your teeth if you think you might have.
I think we can all take that on board. Yeah.
Thank you very much. I'm just going to go online. So, quite a few good questions here. Does reducing hypertension have a direct effect in itself on dementia, or is it only by reducing the incidence of strokes?
Yeah, that's it. And I don't have a direct answer because I don't think anybody's done that specific comparison. But at least the theory is that if you have hypertension in midlife, your risk of having abnormalities in your blood vessels increases as you get older. And part of the result of that is that you may have high risk of heart attacks or strokes, but also of dementia. So it's not a direct effect, it is a long-term effect. But interestingly, and this goes back a long time, but one of the first things that I did was look at MRI scans of people with Alzheimer's disease. And I got in touch with some Swedish colleagues. I said, there are some blood vessel changes in these patients I can see on an MRI scan, and I don't understand them. They're different from the changes in people with high blood pressure and with vascular dementia. And they said, yes, we know, because as people get older and develop dementia, they actually don't have high blood pressure, they have low blood pressure, and they have spells of low blood pressure. And during this low blood pressure, the bits of the brain that are maybe a bit affected are underperfused and to develop lesions there. So it's actually almost the opposite effect. And I mean, that's the second part of my answer. If you actually have somebody who has dementia, it may be the wrong thing to lower their blood pressure unnecessarily, because you get the opposite of what you expect.
And by underperfused, you mean not enough blood reaching that part of the brain, is that correct?
Say again?
By underperfused, you mean not enough blood reaching the brain?
Yes, exactly, yes. I mean, it describes what you see on a blood flow scan, but what it means is there's less blood, less red blood cells, less oxygen, which means that the brain cells are not getting enough energy, which they would need to function properly.
Perfect, thank you. This one may be quite short, but just somebody's kind of summed up a hypothetical situation, at least I hope it's hypothetical. Both of her person's parents had dementia. The father had Parkinson's with dementia. Several aunts also had dementia, and the person themselves, although they have low blood pressure, suffered from depression, anxiety and insomnia for the whole of the last 60 years. Is all they can do enjoy the time we have left and try and eat healthily?
Yes, because they may not even develop dementia.
That's encouraging.
The slightly longer answer there's now if you go to your GP and they say, oh, how tall are you, however you are, what's your BP, and then they take a few blood results and they put it all into a calculator and said, right, okay, we better do something about it. There's a calculator like that that's now available for dementia, and it's on the website, and if you find the paper, you can link to it, and you can figure out what your risks are of actually developing dementia with these risk factors, the most important ones over the next 14 years. If that's an advertisement.
Yeah. I knew this particular elephant in the room was going to come up from somebody. What evidence is there for the use it or lose it concept with regard to cognitive ability? Or would you have to say at the moment that doing crosswords and other demanding brain activities might help, the jury is out still, and just do them if enjoyable? What's your view? I know I didn't plant that one.
So I didn't quite get the end of it, but I think I get the gist of it.
Yeah, so is it just do them if they're enjoyable, or do they have an effect?
Yeah, I mean, there are obviously lots of remedies. You actually mentioned this in your blurb to the talk, that you get all sorts of things you can buy to do brain training, etc. And the slightly more sophisticated people now say, oh, we're doing this so you can actually pick up any changes in your memory, rather than claiming that it's going to prevent you from getting worse. There's one treatment of that kind that is being offered on the NHS as a matter of routine which is called cognitive activation treatment. But the evidence for that is not that people's memory gets better, it's that people's quality of life and their sense of well-being improves. You make of that what you like, but and that's why I tend to be cautious to sort of poo-poo these things, because if there's something you do and you think it's helpful and it makes you feel better, do it. Whether if you do it to a large group of people, whether they actually are less likely than to develop dementia is a different question. But as long as they make the best of their time until then, that's probably fine. Mm-hmm.
So is it that there is no evidence yet? People are doing the studies or they're not doing the studies? Where's it got to?
There are studies. I think it's always important to think about the conditions under which these studies are taking place. If you have dementia, your memory functions are gradually deteriorating. So if you just look at people and look them in a year, you find that the measures deteriorate. You may find that the degree of deterioration is less severe in some people who are engaged in tasks, and this is done in small studies. But to conclude from that doing tasks like that is going to prevent you from developing dementia is too wide a step, because for that you would have to do studies like that over decades, and they're not there. So you can be an optimist and say, well, I take my bet and say, I'll do it just in case it works. Nothing to be said against that,
But don't do it if you hate doing it.
No, don't do it if you hate doing it. Absolutely, yeah. Your stress levels go up. You may become depressed as a result. So don't do it.
Well, I was just going to say, of course, that these kind of puzzles, especially on your phone or online, that's it out. They do have two chemical effects on us. One of them is it can affect the amount of stress hormone. Because for some people, it's a stress reliever. Something to do with how close I am to the amp. But the other is particularly completing games.
I think if you just speak loud, you probably.
Yeah, I'll just go down with a loud voice. If you complete games on phones, tablets, computers, one of the things that gives you is a dopamine hit. We know this is why they become addictive. The idea. So that, of course, can affect the brain. The dopamine affects the brain in a big way. It's one of the things we know. So I guess this is a big puzzle to untangle. It's not there yet.
Well, the short-term effect is maybe fine, but in the long term, you still don't know what's going to happen. Yeah. Talking about interacting with online games and so on, we did a study which was focused on lifestyle, and one of my colleagues, in fact the same, who was the first author of this dementia risk scale paper, and she basically collected all the lifestyle measures that were there, and I think it was from Biobank. And the one factor which really surprised me, and which has been replicated since, is the amount of time sitting in front of a screen, using a computer in old age, right? You still think, well, maybe if your sort of mental faculties start diminishing, you're going to do less of that. There may be a risk of this, reverse causality. But even so, it looked as if, sitting in front of a computer lots of hours is good in the long term in being associated with less frequency of dementia. So I take that to heart, definitely.
I was just thinking,
don't tell the teenagers that as well.
Have we used up all the microphones?
No, it's very odd.
Rachel, we can't hear you online.
Yeah, that's because she switched off her...
I'm trying to be careful because the mic is playing up. I'm just going to have to keep switching it on quickly. How long...
Do you want to...
There is an electrical hotspot somewhere around there.
How long do the effects of head injury remain latent? Does concussion 40 or 50 years ago? Does concussion 40 or 50 years ago still remain a future risk?
Yeah, no, I think I get the gist. So it's a bit like smoking. If you stop smoking, do you sort of come back to square one after a while? I don't think there's a clear answer to that, in that somebody has specifically examined that questions. But if you think about the mechanism of how it works, is if that, for instance, in boxers, if you're knocked out, bits of your brain are damaged and don't think they're like to be replaced. So even if you stop boxing or stop being knocked out, I think you're probably left at that stage. Having said that, you can do lots of things to the brain. The brain is very good at replacing function. If you have a stroke that completely removes the activity on one side of your body, if somebody sees you a year afterwards, you're already using your leg, you're walking, on the side that was completely paralyzed. So the brain is actually, to some extent, is able to replace functions, maybe often not quite as well, but there's this plasticity that allows you to pick up on things that you have lost. And that definitely is related to usage.
We'll give it a go. It'll work better for you, I'm sure.
Are there any good animal models for dementia?
Yeah. The short answer is there are quite a few, but they're based on what we think dementia is. What we think dementia is. For example, the animal models of Alzheimer's are firmly based on the belief that the Alzheimer's disease is the accumulation of amyloid, blah, blah, blah. And there are a number of genes that are responsible for this. Alzheimer's is not a condition that is the same in everybody. I'm just talking about Alzheimer's that occurs later in life, so-called late onset Alzheimer's. There's Alzheimer's disease that occurs early, sometimes as early as in people in their 40s. It tends to be, very severe, very quick in its progression, and it's related to specific genes. And we have there are 2 or 3 genes which have been linked to that. It only accounts for probably less than 1% of all the Alzheimer cases, that we have, but it gives us a very clear model. And then there are animal models which have where there's a specific damage to those genes, and then they can be, they can be followed up, and we can see what effect that has on the brain development and so on and so forth. So yes, there are, obviously for vascular dementia. I'm not an expert, but I'm sure there must be animal models that where you have a high risk of vascular disease of the brain, and you can use those to model it. So because dementias are such a complex and heterogeneous lot, I think it's very hard to find an animal model that answers all the questions. And for instance, these animal models that have been at the center of Alzheimer research in the laboratory are only related to 1% of the illnesses that we see in patients. So you can see that it's scientifically really interesting and important, but from a clinical point of view, it may or may not be relevant for everybody who doesn't have the same mechanism. Does that answer the? Yeah.
For a number of years, I spent my time as a house leader in a school for boys with special needs, and I'm wondering whether you have any interest or have been reading much about boys with autism, particularly Asperger's, which is a very high area of autism. But I think lots of, I get very worried because lots of people, even police, don't treat people with autism as they should be treated.
Yes. I think the short answer is no, I don't have expertise, and I don't know whether there's very much on dementia and autism. What I do know is that in Down syndrome, for example, which affects chromosome 23, where one of the gene sets which are associated with very early onset dementia. So people with Down syndrome usually have Alzheimer type changes in their brain in their 40s. And it's sort of difficult in some cases to determine whether somebody's dementing, because you'd have to identify that they function less well than they did before. But as a matter of principle, I think they say that most people with Down syndrome, in the end, if you look at their brains, show clear signs of Alzheimer's disease. And they show other signs. But it's the kind of Alzheimer's disease that occurs on a genetic basis. It has certain similarities with what you see in older people as well, but it's not exactly the same. But it's certainly people are aware that this is a problem in the general community, as far as homes and accommodation is concerned. There is as people, particularly with Down syndrome, live longer and longer. There's now a group of people developing there who have this additional problem that needs to be addressed and that needs to be sorted. I'm not an expert in other specialties. There are some, conditions that develop or that present with learning disability earlier on, where that may also be the case, but I'm not an expert on that.
It appears a lot of the information we had seemed to indicate that it is usually passed down through the female line, and it is an inherited form of disease, autism. Get quite annoyed really when you see that even families, parents, they seem to think that the autism is just irritation or annoyance or something that's taking place with their child, and they don't understand the autism properly. So often when children came back from August holidays particularly, we had to treat them all over again to the
Sorry, we just need to turn it off and then on again. If you want to carry on. Just intervene here if you need to.
This is waterfall building up inside, yeah.
But yes, I mean, I even had one boy who I was the appointed caregiver for in the school, and but
we just need to clear it. We can't fix this quickly. We'll clear it on time. Get going again quickly.
Can you hear the irons building up in the background?
Try battery. Just give us a moment. We've still got a few more minutes. Sorry, that didn't occur to me. You're right there. I'm sure it will be that. Right.
yes, I'm one of the boys that I was the main care worker for. Phoned me up once, a few years later, and apparently he was in prison, and he said, "You'll never know who's next door to me. It's Berta, which is another boy." And there's a clearly they just don't understand the condition in many cases, and so they don't treat them properly. And these days, a lot of them are in fact going to normal schools where they don't really integrate properly. So that causes their intelligence to wobble slightly, but it also has a great effect on the rest of the class that they happen to be with. So it's a bit both ways that can slow things down for them. It's very worrying the way they're.
We want to stay on the dementia subject, I'm afraid. for this one. One thing I'm going to just put in, which was in the chat, and I will send the link round on the mailing list, 'cause I think it's a good one. Somebody's saying that they've been on the PROTECT study with KCL and another university, but my chat is cleared, so I can't see which one. And that's been working for kind of 40 years to look at cognitive activities that can potentially have an effect on the brain, and just saying that it's quite useful. So it's a nice bit of input there. Got the chat up. Thank you. That's right. So long-term study. They're currently the 40 years. Sorry, they're currently recruiting people over the age of 40. I think probably last question will be: do any of the studies distinguish between type 1 and type 2 diabetes, and any connection or correlation there?
Again, I'm not an expert in this, but I would suspect that the vast majority of those cases would be type 2. And I would not be surprised if the distinction wasn't made, that people just ask diabetes and then they don't care whether, because in practical terms, in older age groups, even people with type 2 diabetes will receive insulin, so you can't even tell a difference from the treatment, Yeah, I think that's probably the answer, but it's quite possible that if you look for type 1 diabetes, you may find that there's a separate literature trying to examine the links, but of course that has a very early onset, so you can think there are already logistical problems to follow people up for 40 and 50 years rather than just 20 years.
Yeah, although of course type 1 often, it depends on how good people are, but it can be very well controlled. And it's type 2 where there's more impact on blood pressure, particularly, which again goes back to what you were saying about the brain. I think that's the most fascinating thing to come out of tonight, that kind of connection there. Right, I'm going to close up because we do have to stop at 8:45 and we're very, very nearly there. So I'll just say now on this video that through slight incompetence of mine, we didn't manage to record the first bit of the talk. What I'm going to do when I go home is I'm going to run through the slides very slowly, just adding in a few comments to mirror what Klaus said, so that if people want to go back, they can look at it in a bit more kind of real time with the slides. Obviously, the discussions covered quite a lot that was mentioned before anyway, so I think that's probably the best way to do it. But my apologies to Klaus, because it was a really good talk, and I'm really sorry it's not being captured. We will not make that mistake again. Obviously, my usual thanks to Pharmacology for allowing us to be up here, which is just so great of them. This is after the working day, and they do close the building at 9, which is why we stop bang on time. My biggest thanks, of course, to Leo and Kelly for helping, because it's fantastic of them to come and do this, and to you guys for coming, whether online or in the room. Looking forward, so to next year, or this coming year, is filling up quite nicely. There are a couple of options as to who will be in October, which is why that is not there yet. Got people from Klaus's department coming in November to talk about actual treatments for depression, so looking at the medication side of that. I thought it was very nice to hear a psychiatrist saying, I don't care whether it's medication or psychiatry, just get some help. That was very refreshing, thank you very much. There's a few more kind of coming up in the new year, some for next summer. I will start trailing now, but I will say it near the time. Our May date will be 1 week earlier than normal, because I'm catching somebody who is normally out of the UK and is doing a bit of coming around Oxford doing some various events. So I'm going to catch him while he's here. So May will be on the 7th of May, not the 14th. So it'll be 1 week early. But actually that then makes it 5 weeks rather than 6 and 4, which is very good news. So that's all right. And as usual, we'll carry on as we normally do. We will be recording everything next time. The videos will generally go up a little bit later than the actual evening itself. My thanks to everyone for participating. I don't know if they're still all there, but at the beginning we certainly had over 50 people online. So it's a fairly big crowd that's been here for this, which is great. And thank you all for coming. And our biggest thank you to Klaus. Thank you. Recording.